All right, so welcome back to your favorite Inorganic Tutor YouTube channel once again. Today is another video. We are going to look at integration by part. We have dealt with the formula approach. This time around, we are going to use the tabular approach to make work so easy, so swift, very fast for you to appreciate the integration by part. And of course, students taking the differential equation, ordinary differential equations, you really need this approach to make your work so easy, right? So let's look at some problems under the tabular approach, right? So we are going to use the tabular approach to solve this integration by part problem. So of course, it's going to be our first problem. 6x e power 3x dx, right? So the tabular approach, you know that you always choose your u to be the function that you can differentiate to a constant, and your v to be the other part, which is the integration aspect. Good. So we have our v, our u here to be 6x, and our v to be e power 3x, right? So create your table for it. That's what we call it, tabular approach. So create your table, differentiate this part to a constant. So differentiating 6x, you have 6. Differentiate again, you have 0, right? Now, integrate this part, you have e power 3x over 3. Integrate again, you have e power 3x over 9, right? So this is the end of the work. You match this to this to that. Then you effect the signs. This is the crucial aspect. If you forget the signs, you are doomed, because that is where it's going to show whether you get it right or wrong. So first plus, second minus, in that order. If there is another one, this part is going to be positive. So this is what we have. This times this, then we have 6x e power 3x all on 3. Then 6 times negative, right, times this right here. So we have negative 6 e power 3x all on 9 plus a constant of integration, right? We know that this will take off this 2 times, right? So we have 2x e power 3x minus 3 go here 2, and 3 will go here 3, right? So we have 2 on 3 e power 3x plus a constant of integration, right? You see how fast this is. So this is very good when you are working with differential equations, right? So this is our final answer. You can look right here, as this is our final answer, right? So let's go to the second problem. So our second problem is going to be integral of 12x cos into 3x dx, right? So we have u equals 12x, right? And our v equals cos into 3x. So you create your table, right? Good. Differentiate this, you have 12. Differentiate again, you have 0. Come to this side, integrate. When you integrate that, you have sine into 3x on 3. Then integrate again, you have negative cos into 3x on 9, right? So we just have to apply the signs, right? So this moves to this, and this maps to this. So this becomes positive and this becomes negative. So this times this, and then you have positive 12x e power positive 12x sine into 3x all on 3. Then this times this. Of course, you have negative here, so and negative 2 is here, right? So you have to be very careful with the signs. So you have plus 12 cos into 3x all on 9, right? Plus a constant of integration, but we can see that 3 can go here, right? So we can have this, we can have this 3 can go here 1 and 3 can go here 4. 3 can go here 3 and 3 can go here 4. So we have 4x sine into 3x on, okay. So this plus 4 cos into 3x all on 3, right? Plus our constant of integration, right? And this becomes the final solution to this second problem, right? Yeah. So let's look at the third problem. The third problem, right? Right. So our third problem is going to be the integral of negative x sine into 2x dx, right? So our u here is negative x and our v is sine into 2x, right? So we have our table being created. Differential of this is negative 1. Go down again means 0. Differential of sine, this is integral, right? So integral of sine, we have negative cos into 2x all on 2. Then integrate again, we have negative sine into 2x all on 4, right? So this right here, let's effect our sign. So positive, negative, right? Negative x times negative cos, right? So we have positive x cos into 2x all on 2. Then negative 1 times negative, right, is going to be positive times negative again, and we have negative, right? So we have negative sine into 2x on 4 plus our constant of integration, right? So this becomes the final answer to this particular problem, our problem number 3. You see how fast the tabular approach is. So interesting. Let's look at the fourth problem. All right. Our fourth problem is going to be x sine 6x dx, right? So we know right here that our u is equal to x and our v is equal to sine into 6x, right? So this right here, we have this differentiated, x differentiated, we have 1, go down again, 0, right? The integrate the v, which is the sine 6x, and we have negative cos into 6x on 6, right? Go down again, then we have negative sine into 6x on 36, right? So you are done with whatever you want to do. What you have to do is effect the signs, right? So this maps to this, and we have plus here. This maps to this, and we have negative here. So this x times negative cos, right? So you have negative x cos into 6x on 6. Then 1 times negative is negative times negative. So you have positive, right? So we have plus sine into 6x on 36, right? Over here, we can decide to factor 1 on 6 out, but of course, it changes nothing. You can leave it this way as well. So we can say that our final answer to our problem number 4 is this, right? So see how fast you're going to end this tabular approach, right? Right, so our fifth problem is going to be integral of 2 minus x e power negative 3x dx. Right, so we know that our u will be equal to 2 minus x and our v will be equal to e power negative 3x. So you create your table for it, differentiate this, you have negative 1. You go again, you have 0. Now you come here, integrate, you have e power negative 3x on negative 3. Then you go again, you have negative, of course, you're going to have positive 9, right? Good. So now you are done with this. You effect your signs. So this maps to this, of course, positive. This maps to this, of course, negative, right? So this time this, we have negative here. So we have negative into 2 minus x e power negative 3x all on 3. Then negative times negative, positive. This is positive, so it's going to be plus e power negative 3x on 9. Of course, plus a constant of integration. And this becomes our final answer to problem number 5. Let's look at our sixth problem, which is x integral of x squared e power 4x dx. Right, so your u is equal to x squared, and our v is equal to e power 4x, right? So we have this right here, this goes away. This differential of this is going to be 2x. Go down again, you have 2. Go down again, you have 0. This integral of e power 4x, know that you have this. Go again, over 16. Then this 16 times 4. 16 times 4, 6, 14, 4, 64. So we have 64 right here, right? So this, we have the signs positive, negative, positive, right? So now this moves to this, and you have s squared e power 4x on 4. 2x times negative, right? So we have negative 2x e power 4x on 16. Then 2 times positive, right? Then this is also positive. So we have plus 2 e power 4x on 64 plus a constant of integration. But of course, we can simplify some of the letters, right? So when we do that, plus a constant of integration. But of course, we can simplify some of the letters, right? So when we do that, we're going to have s squared e power 4x on 4. Then 2 go to 16 8 times, so we have minus x e power 4x on 8 plus 2 in going to 64 32 times. So we have 1 on 32 e power 4x plus our constant of integration, right? So this also becomes our final solution.